So just a reminder, late work from before winter break must be done by next Wednesday. 4-week progress reports are going to be done, I believe, next week, Friday the 15th. So I need you to get that work in before those progress reports go out so that your grade on your progress report is accurate for what you're doing in class. And then again, the 4-week progress report is where we kind of deadline everything. Typically, it would be everything assigned before then. However, I like to leave the current chapter open. So 1.3 and 1.4 material all due next Wednesday. All right. So for today, what we are going to do is lesson 4.1. Solving systems of equations by graphing. So the next couple of weeks are all going to be on this thing called solving systems of equations. And we're going to use 3 different methods for solving systems. And so we're going to start today with one that can be pretty easy. If you're a good grapher, if you graph lines really well, this lesson will go really well for you. If you're struggling with graphing lines, well, this will be a good opportunity to practice. All right, so a system of linear equations is a set of 2, should be or more, linear equations in the same variables. So we're always going to work, or for our examples, we're working with the variables x and y. So all of our equations should have the same variables in them. Again, it could be 2. Most of what we do, all of what we do today will be 2 equations, but it could be more, and we'll do more later on. The solution to a system of linear equations is an ordered pair, x, y. It's a point that satisfies each equation in the system. That is a fancy way of saying that that point is on both graphs, or makes both equations true. So on a graph, it would be a point where our 2 lines intersect. That's going to be the key for what we're doing today. All right, so getting right into it. The easiest form will be when both equations are in that slope-intercept form, y equals mx plus b. So just as a bit of a review, when I graph, so I'm going to graph this first equation. I'm going to start by graphing the y-intercept. And after I graph the y-intercept, I'm going to graph other points using the slope. So my y-intercept is -3. My slope is 2/3. And I'm going to use rise over run. So that says I go up 2, right 3. I go in the positive direction for both. up to right 3. Now, sometimes you won't have enough room. So what you'll have to do is remember that up to right 3 is the same as down to left 3. 1, 2, 3. And the key for solving by graphing is making a large graph. So you'll see I'm going to use as much of the grid as I can. And then I'm going to be as accurate as I can. It's pretty good. The more accurate our graph is, the easier it's going to be to read solutions off of it. So when you're doing these problems, if you have a ruler, that would be great. Graph paper works well. Again, if you have the packet in the back, there'll be those blank graphs that you can use. My second equation, I'm going to graph the same way. Start with the y-intercept, 8. Then use the slope, 5/2. So rise over run, go up 5. Well, I can't go up 5. I don't have enough room. So I'm going to go down 5 and left 2. And because I'm going in a negative direction and a negative direction, a negative divided by a negative is a positive. So that's still going to give me that slope of positive 5/2. And so on. Drawing my graph. And you can see there's the point of intersection. So my solution, -6, -7. And then you'll notice this great last part, check your answers. So I'm going to check this one. And the way I'm going to check it, I'm going to take -6 and plug it in for X, and take -7 and plug it in for Y. And I'm going to do it for both equations, because by definition, this point should be on both graphs. So it should make both equations true. So let's see if that works. If I use my first equation, -7 is my Y value. I like to put a question mark over my equal sign when I'm checking, because I'm not sure yet if they're equal or not. So the left side is -7. On the right-hand side, I have this 2/3 times -6. So to do that, I am going to take 2 times -6. What is 2 times -6? You can either put it in the chat or shout it out. Yes, 2 times -6 is -12. Then I'm going to divide that by 3. So I have 2 times -6, which is -12, divided by 3. I'll help you out a little bit. It's going to be negative. Yes, excellent. Several good responses in the chat. -4 is the answer. And so then if I take -4 and subtract 3, I do get -7. And to show that my check is done, I always put a check at the end. You'll notice because both sides are equal, I don't put the question mark over the top anymore of the equal sign. So -7 equals -7. That's half of my check. Now I'm going to check with the other equation as well. So again, y is -7. 5/2 times -6 plus 8. And question mark over the equal sign because I'm not sure if they're equal or not. All right. So similar process here. I'm going to take 5 times -6. And what is 5 times -6? Yes. All right. Several -30s for an answer. Excellent. And then I'm going to divide that by 2. So what is -30 divided by 2? Yes. Excellent. Excellent. -15. Plus 8. So -7 does indeed equal -7. And that checks. So this is a good solution. You won't be checking all of your solutions, or you won't have to check all of your solutions. But this is one of the few times in math where you can come up with an answer and make sure it's correct just by running those quick checks. And there, you can also do this on your calculator. Maybe I'll try with the next one. Hopefully the computer wasn't liking it yesterday, trying to run the calculator and everything else. So we'll see if it works today. All right. Second example. Y equals -1/4 x plus 6. And y equals -x plus 9. So again, with this first equation, I'm going to start with my y-intercept at 6. My slope is -1/4. Thinking of rise over run. Now this is, be careful here. I'm going to always use the negative with the rise. So instead of going up 1, I'm going to go down 1 because that's negative, and then right 4. Otherwise, I could go up 1, and then I'd have to go left 4. And you can always check is that a line with a negative slope? Well, yes, because it goes down as we go from left to right. The second equation, we have a y-intercept of 9. What is the slope on my second equation? All right, I got like several answers there. When there's no number in front of the x, we just assume it's a 1. So, but we also have to take care of that negative sign. So the slope in this case is -1. So for rise over run, anytime I don't have a fraction, my bottom number is going to be 1. So this is down 1, right 1. As many times as I want to graph it. And there's my point of intersection. My x coordinate is 4. My y coordinate is 5. Excuse me. Again, checking my answer, going into the first equation, 5, is that equal to -1/4 times 4 plus 6? -1/4 times 4. We can take -1 times 4 and then divide that by 4. So what is -1 times 4? Yeah, -1 times 4 is -4. Excellent. And then if I divide -4 by 4, what do I get? -4 divided by 4. Excellent. Excellent, excellent, excellent. -1. And -1 plus 6 is 5, so that checks. The second equation actually checks much easier. Whoops. And it checks a little bit easier because of that negative that's in front of the x. So there's really, I mean, we could say -1 times 4, but that's just going to give us -4. We found that out from the first part of the first equation check. So really, I'm just taking -4 plus 9, which is the same as 9 minus 4. And it checks. Now, I will try real quick to get my calculator up, and I will show you one way that you can check with a calculator. All right, so I'll check that first one, y equals -1/4 x plus 6. And what I'm going to do is ignore the y equals part. So I want to just concentrate on -1/4 x plus 6, but I know my x value is 4. So if I take -1/4 times 4 plus 6, and what I really want to see is that value that I got for y to come out as my answer. So if this is equal to 5, I know I'm in good shape. And there it is 5. For the other equation, we had the opposite of x, which was 4, plus 9. And that too gives me a value of 5, which is what we want. So if you use your calculator, you need to just choose the, in this case, it's the right-hand side of the equation and plug your value in for x. Your answer should be your value for y. And then that is our answer. All right. So far, so good. So it's great when we're given equations in slope-intercept form. We won't always be given equations in that form. So here's an example where we have one equation in slope-intercept form and one equation that is not in slope-intercept form, and we'll deal with that when we get to that second equation. So it just says, what is the solution of the system of equations, and use a graph to explain your answer. So if I graph y equals -3x plus 5, again, 5 is my y-intercept, -3 is my slope, so down 3, right 1. And I'm going to draw my line in. There we go. For my second equation, I have a couple of choices. What I could do, because it's not in slope-intercept form, I could like pick a value for x and find out the value for y, and then pick a value for y and find the corresponding value for x. Normally, when we do that, we like to use intercepts, like plug 0 in for x, figure out what y is, plug 0 in for y, figure out what x is. In this case, that would give us some fractional answers, and that's not really a great way to find an exact value. So instead, what I'm going to do is I'm going to get the y by itself. So I'm going to solve this and get it into that y equals mx plus b form. So the first thing I'm going to do is subtract 15x. So I'd have 5y, because on the left-hand side, 15x minus 15x is 0, On the left-hand side, I can't do that subtraction because my 25 doesn't have an x with it. So I just have to write it as minus 15x plus 25, and they can't be combined. Then I need to divide both sides by 5. And so I'm dividing everything by 5 to get y equals negative 15 divided by 5 is negative 3. 25 divided by 5 is 5. So y-intercept is 5. Slope is negative 3. And if I graph that line, you'll notice it's the same line. That's a special case when we get the system with the exact same two lines. Our solution is infinitely many solutions. And using the graph, it would be because the equations represent the same line. Now, if you want to sound really smart, those are called coincidental lines, or the lines coincide. In this case, it's the same line. Every point on that line would be a solution for our system, because every line, or every point, sorry, every point would make each equation true. So that's one of our special cases. Infinitely many solutions when we have the same line. All right, let's go to this next example. What is the solution? Use a graph to explain your answer. Again, our first equation already in slope-intercept form. So my y-intercept is 6. My slope is 2, up 2 over 1. See if I can make my graph a little bit better. Okay. My second equation, again, isn't quite in slope-intercept form. So what I'm going to do is the y is by itself. I just need to divide everything by 2. 4 divided by 2 is 2. 8 divided by 2 is 4. So the second equation has a y-intercept of 4 and a slope of 2. And so making as many points as I feel I need to. And we said that our solution is going to be the point where the two graphs intersect. In this case, they don't intersect. So this one is no solution. No solution because the lines are parallel. All right. So what we're going to do, I'm going to give you a couple of minutes, and I want you to try these two examples. And I will mute myself and turn my video off so you don't have to see my gorgeous face. But I'm just going to give you like 2 minutes, and I would like you to graph and solve those two systems. And then we'll come back and take a look at the answers. So take your 2 minutes and we'll take a look at answers in 2 minutes. All right. So if we look at the first one here, and you'll notice when I graph these, I always graph in 2 different colors. That's just my way to differentiate between the two equations. And 8 is up 1. On your homework, if you're plotting points in Schoology on a homework assignment, you actually don't have to draw in the point. You can just click on where you want the point to go and it will put a dot there. So don't feel you need to try to color in dots and make a drawing. You can do it with just dots on the, just by clicking on the grid. Excuse me. Whew. So -1, 7. For the second one, there we go. And solving the second equation, getting the y by itself, I subtract 4x. Then I divide by -8. A negative divided by a negative is positive. And there, a positive divided by a negative is a negative. And so this one, if we look, we have the same slope, different y-intercept. So those lines are parallel. So we get no solution. All right. So again, what I'm going to do is give you a couple of minutes to try these two. And then what I would like you to do is, as you finish them, put your answers in the chat. So for instance, when you get the first one, if you can just go into the chat and go 3 period, and then put the point where they intersect. Or if it's no solution, write no solution. If it's infinitely many solutions, type in infinitely many solutions. Go ahead and try those two. Again, I am going to mute myself. If you have a question, you can certainly ask it in the chat, and I will keep an eye on that. And but I'm going to give you some time to take a look at those. All right. Yeah, excellent. Several people getting the answer for number 3 here. It's still working. Okay. Okay. And that's okay if you're still working. I'm going to start at least with the description. And here, the first equation isn't in slope-intercept form. So one thing I could do is subtract 2x from both sides and get y equals negative 2x minus 4. All right. Um, and down 2/1. The second equation is in slope-intercept form, so that's good. And we get -4, +4 for our solution, which I saw from a lot of people for the first system. Our second system, again, that first equation is all ready to go. And we have um, differing opinions on the solution for this one, so. We'll see if we can get it figured out. There's our first line. Pretty good, maybe off a little bit. Ooh. Aha, I see why it's off. I had the wrong points in there. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. There we go. I think that's better. All right, second equation. Again, subtract 3x from both sides. Divide everything by 2. So y equals -3/2 x plus 5. And look at, we have the exact same equation, which means the lines are going to be the same. And when that happens, we get infinitely many solutions. And you could, you know, I can certainly go through and put the points in. And draw in my line. So the difference in the equations for infinitely many and no solutions is for infinitely many, the equations are exactly the same. For no solution, the only difference is that y-intercept. And I did see a few of you commented back that had no solution. Oh, I forgot to divide the whole thing by 2. So just, you know, be very aware of those things as you're working on those problems. All right. So here we have a little quick write. If you had the system of equations, four x minus 5y equals 2, and 7x minus 5y equals 9. Would you think that graphing would be a great way to solve that system? With the way the equations are written, are they going to be relatively easy to graph? Yeah, no, probably not. So this one, I would say no is a good answer. One reason might be the equations are not in slope-intercept form. Now, that doesn't that doesn't mean we couldn't use graphing to solve them. It just wouldn't be as easy to do. Yeah, there you go. Excellent. So someone actually put that in as their chat, that we could if we wrote them in slope-intercept form, and that's exactly true. All right. So here you're given a system that's already been graphed, and you're asked, could you find the exact solution? Could you tell me exactly the point where those two graphs intersect? Okay. So we do have a point of intersection, but do I know the exact X and Y coordinates? If I do, then the answer is yes. Okay. If I don't know the exact coordinates, then the answer obviously is no. I would have to make an estimate. And so could I solve this system exactly? No, not from the graph. And so what we'll look at on um, Friday and next week is how to deal with solving systems in other ways. So sometimes we'll have graphing, and then we'll also have a couple different methods starting on Friday.